Guys, this is going to be a really quick video. We're just going to go over a couple of the questions on the review. We're not going to talk about all of them. So if you're confused on one of them, you can either email me or you can go back to the videos when I explained the topic from before. But let's just go through a few of these. So just a review, if you have a periodic table like this, something similar, you know, this is like what your periodic table kind of looks like. Any of the columns going down like this, these are groups. So this would be group 1A, group 2A, and then on this side you have 3A and 4A, all the way down to 8A being your last group. Alright, so if it's asking for something in group 3A, you'd have to go to this column in group 3A, find the different elements and circle which one is not. Make sure you're doing is not. Alright, so this next one, hope you guys have some practice with that. The next thing is talking about valence electrons in the outer shell for elements that are noble gases. Remember, noble gases are in group 8A. You also remember that that number before the A, either 1, 2, 3, 4, 5, 6, 7, or 8, tells us the number of valence electrons. So if it's something in 8A, it's going to have 8 valence electrons. If something in 3A, it'll have 3 valence electrons. Something in 1A, 1 valence electron. Alright, the next thing is talking about principal energy levels. So those are periods. So remember, those are the rows that are going across our periodic table like this. So this is a period. Each one of these rows is a period, and it goes all the way across. So all these elements would be in the same period going across your periodic table. So the important thing about periods is that they have electrons that are all on the same energy level. So that's an important thing to know for that. Then the next thing we're starting to talk about is our trends. So we labeled those on your periodic table. I would definitely go back and watch these videos because we are not going to cover them, all of them, but they're really important for your test. So go back and watch those videos, and you'll be able to see general trends for them. We'll do this one for right now, and you can go do the other ones by yourself. So on your periodic table, this is my rough sketch of one. We know that as we go across it this way, it's getting smaller. And as we go down this way, it's going to get bigger. So we need to find ones that are going from large to small. So we know that down here are going to be large ones, and up here are going to be small ones. So this is where we have big ones, and this is where we have small ones. It kind of goes in a diagonal pattern. So if you look on your periodic table, and you find each one of these, you'll notice... Here, let's see if I can find a periodic table. Here's a periodic table. So we want to find large ones kind of down here and small ones up here. So down here we have like RB, SR, CS, BA, FR, RA. Let's see if we can find any of those. So you can find like BA right here. So that one's a pretty big one. Let's see if CL is a small one. So up in this corner we see CL. It's a small one. So you know that this one going from BA to CL is going to be going from large down here at the bottom to small up here at the top. The next one says, what charge will F have if it loses its electron to have a full octet? F is going to be found on your periodic table. F is found in group, it's 7A. So remember, all elements are trying to get to group 8A. So if it has 7 valence electrons, we want it to gain 1 electron to get to 8A. So if it's gaining 1 electron, it's going to gain a negative charge and it will be -1. There was a typo here that's supposed to say gain, if you're confused. Alright, this is just a matching for your second one. Hopefully it's not too tricky. The next thing is a fill in the blank. So let's just do a couple of these right here. This one is probably the hardest one. It says, moving from top to bottom in a group of elements, the ionization energy tends to decrease. This is partially due to the outer electrons being blank from the nucleus. So our ionization energy decreases as we go down our groups. So remember, if we start at the top of our group, we'd have a nucleus and we have electrons that are really close to it. And then remember, with each period that we go down, we're adding another level. So you can see your nucleus, and we keep adding more and more levels to where our electrons are. So finally, down here at the bottom, are they going to be closer or further from our nucleus? So hopefully you'll be able to see that since we've added all of these rings here, we've added rings, that it's actually going to start getting further and further away from our nucleus. So this one would be further. So then the next thing is actually a really tricky one. It's saying if fluorine is more reactive than chlorine, which is more reactive than sulfur? So let's go up to a periodic table again. So for this, we are saying, remember it said that fluorine, this one, is the most reactive. And this one is less. So then it's asking us, if we have a sulfur one, which one's going to be more reactive than sulfur? So if you notice this pattern from going from bottom to top, it gets more reactive. As we go from sulfur up top, it's going to get more reactive, so it's going to be oxygen for that one. So this one would be oxygen, or O. Let's skip down to this potassium one. So if it loses an electron to have a full octet, so we have to see how many electrons it would lose. So up here, potassium is right here on your periodic table. It's in 1A, so it has 1 valence electron. So if it wants to get to 8A, remember, it's not going to gain all 7 electrons. That's a lot of electrons to gain. It's actually going to lose this 1 electron to have 8. It's like lithium here, kind of. If we lose that 1 electron, then our shell is happy. We're not going to just gain a ton. So we're going to actually just lose 1 electron because it's in the 1A group. Remember, if you lose an electron, potassium would have a +1 charge. All right. We'll do these last two because they're both a little bit tricky, and then hopefully this will be good for you guys to figure out the rest. So it says blank is the most electronegative element. This is actually the electronegative chart right here. And so when we look at it, if it has a higher number, it's more electronegative. So you can see that F right here on your periodic table is the most electronegative. We also know that follows our trends because as we go across, it gets more. And as we go down, it gets less. And so since F is in this upper corner, we know that it's going to be the most electronegative. So this one will be F. And then this last one, some people in class are having trouble with it, so let's talk about it. Consider an atom of boron. It has blank valence electrons, and its most common ion has a charge of blank. So boron is here on our periodic table. So it's in group 3A. So how many valence electrons does it have? Yes, it has 3 valence electrons. And so remember that for boron, it's going to lose those 3 electrons and become a +3 charge. All right, because it's easier to lose 3 electrons than to gain all 5 electrons. So it's going to lose 3 electrons and have a +3 charge. If any of that was confusing, please email me or make sure to check the video for whichever section you felt was confusing for you. Good luck studying for your test. And I know you guys are going to do awesome because for those of you who have been doing work this unit have done really well on your stuff. So I know it's going to be great. Good luck. Let me know if you need help.